A function is a relation in which every element of the domain, input, is associated with exactly one element of the codomain, output. Functions are widely classified based on their algebraic form and behavior. 1. Linear functions. These are of the form fx equals ax plus b. Their graphs are straight lines with slope a and intercept b. They represent constant rates of change. 2. Quadratic functions. Expressed as fx equals ax squared plus bx plus c, they produce parabolic graphs. Depending on the sign of a, the parabola opens upward 0 or downward a tie 0. 3. Polynomial functions. Generalizations of quadratic forms. They involve higher powers of x, e.g. x3, x4. Their graphs vary in shape depending on degree and leading coefficient, often showing turning points. 4. Rational functions. Defined as ratios of polynomials, such as fx equal x plus 1, x my 2. Their graphs may have vertical or horizontal asymptotes, reflecting points where the function is undefined or approaches infinity. 5. Exponential and logarithmic functions. Exponentials take the form f of x equals a trace, a equals 0, a equal 1, showing rapid growth or decay. Logarithmic functions, f of x equals log x, are their inverses. Their graphs demonstrate opposite behaviors. 6. Trigonometric functions. Functions like sine x, cos x, tan x describe periodic oscillations with graphs repeating over intervals called periods. 7. Piecewise and absolute value functions. Piecewise functions are defined by different rules in different intervals, while absolute value functions, f of x equals x, produce V-shaped graphs. 8. Special functions. Step functions, sine functions, and identity functions also appear frequently, each with distinctive graph forms. Graphs of functions of real variables. Graphical representations. The graph of a function provides a visual representation of the relationship between input and output values. It is drawn on a coordinate plane, with the horizontal axis representing the independent variable x and the vertical axis representing the dependent variable f of x. Graphical representation serves multiple purposes. Visualization of behavior. By observing a graph, one can identify trends such as increase, decrease, constancy, or periodicity. Domain and range. The portion of the x-axis covered indicates the domain, while the extent of the y-axis shows the range. Intercepts. The graph intersects the axes at points called intercepts, revealing solutions or initial values. Symmetry. Graphs often display symmetry. For instance, even functions f on x equal fx have symmetry about the y-axis, while odd functions ff on x equal myfx have symmetry about the origin. Asymptotic behavior. In rational and exponential functions, graphs reveal limits that values approach but never reach. Transformation effects. Shifts, reflections, stretches, and compressions can be interpreted graphically, illustrating how altering parameters changes the function's shape. Thus, graphical representation is an essential tool for interpreting mathematical functions. It provides immediate insight into the function's properties and enables real-world applications in physics, engineering, economics, and other fields.
We share.
Tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.